So once again, welcome back. We'll be starting with a new topic, that is solving an LPP problem by the simplex method. Okay, so previously we saw the graphical method. Now we'll be seeing simplex method. Okay, simplex method itself, we can solve it by different methods. Like we have big M method, we have phase two-phase method is there. Okay, like that we have different methods. But now we'll be seeing some procedures. Okay, there are some steps to solve the simplex method. Okay, and these steps are followed when we have the constraints of the type less than or equal to. Okay, so when we are having constraints of the type less than or equal to, we'll be solving the LPP model with the following steps. Okay, we'll be seeing one by one. Okay. Just listen here. Okay, I'll be telling the steps one by one, and then you can, I'll explain it with the problem. First step is formulate the problem into a LPP model. Okay, for that we have some steps. Minimization problems must be converted into maximization problems. Okay, you know already, right? The LPP problem, we have two types. One is maximization problem, the other one is the minimization problem. Okay, if in the question you are getting a minimization problem, then what you have to do is you have to convert it into a maximization problem. Okay, once you convert it into a maximization problem, the steps that you have to follow will be the same. Okay, every time you have to follow the same standard steps. Okay, so initially, if you get a minimization problem, convert it into a maximization problem. And how will you do that? How can you convert a minimization problem into a maximization problem? That is, just look the step over here. Minimize z is equal to, okay, you are actually putting a minus sign over here. You write max. Again, for the z, you put a minus z. Okay, so you are putting here 2 minus into minus, it will become plus. So in effect, there is no change. But for solving this problem, what we are doing is minimization problem has to be converted into a maximization problem. Okay, so what happens over here is I'll just show with an example. See, suppose they are in the question, you get something like minimize z is equal to, okay, minimize z is equal to 4x1 plus 3x2. Okay, if you get a question like this, then you have to convert it into the maximization problem. How will you do that? Minimization z is equal to minus of maximization of minus z. See over here, minus and minus. So in effect, there is no change, but we are converting it into a maximization problem. Okay, for that, what you should do? Minus of max. I'm putting this minus z over here, no? So I'm taking this minus up. Okay, minus of, which is the z value? This is the z, right? Z over here is 4x1 plus 3x2. So I am multiplying minus of 4x1 plus 3x2, which is equal to minus of max. I'm taking the minus inside. So it becomes 4x1 minus, okay, this minus I'm taking it inside. So it becomes 3x2. Okay, so this much. Okay, so I'm calling this one as, this z as, I'm calling it as z star. Okay, so I'm putting minus of max. I'm calling this one as z star. Okay, max of z star is equal to minus of 4x1 minus 3x2. Is it okay? You will be solving from this. For the below steps, no, you will be taking only this much. Max of z star is equal to minus 4x1 minus 3x2. Okay, and then you will be solving with the usual steps. We see over here we have the usual steps written over here. So taking these steps, you will be solving this maximization problem. Okay, at the end you will be getting one answer, right? Z star is equal to, for example, 441. If you get like that, then you need to convert it into the minimization problem, back into the minimization problem. For that, what you should do? What was our equation? Our equation was minimize z is equal to minus of max of minus z. Okay, instead of this minus z, we already have the z star. Okay, instead of the minus z, we already have the z star over here, which is equal to 441. So to get back this minimization value, we need to again multiply by this minus sign. Okay, because in effect it has to be normalized, right? Okay, so it becomes minimize z is equal to this minus, we have to put it down. So it becomes minus 441. Okay, this type of problem we'll solve it as the second case. Okay, for this, for the time being, you will have to know only this much. We'll be solving problems of this type. Okay, just because there's a step in the problem, I just there's a step like that. No, I just explained it. Okay, you don't have to worry if you don't understand it now. We'll solve it when we have the when we see such a problem. Okay, minimization problem, we'll solve it using that step. Okay, now I just wanted to explain how this works out. Okay, so that is about a minimization problem. If you get a minimization problem, convert it into a maximization problem. Okay, what is the next one? Ensure non-negative right-hand side for constraints. Okay, you know, we have an objective function for an LPP problem as well as we have the constraints. Okay, constraints should have a non-negative right-hand side. Okay, for example, see in our case, I'm writing a constraint. We usually write subject to constraint and we write an inequality constraints, right? Okay, for example, 4x1 plus 3x2 is greater than or equal to minus 3. Okay, so what does our step say? If we get a constraint like this, okay, the constraint should not have a negative number. It should not have a negative number. Negative number should not be there in the constraints. So we have to convert it into a positive number. So how do we convert it into a positive number? We have to multiply it. This negative can be changed into a positive number by multiplying it with negative 1. So we have to multiply the equation with the inequality with the negative 1. Okay, multiply with negative 1. So our constraint will become 4x1, sorry, minus 4x1 minus 3x2. And the inequality will also change. Over here we have greater than or equal to. When we multiply with minus 1, the inequality also will change. It will become less than or equal to 3. Okay, is it clear now? So anytime you check the constraints, okay, if you get it as minus negative on the right hand side, then you have to immediately convert it into a positive sign. Okay, how do we do that? By multiplying both sides of the inequality with minus 1. Okay, in such case, you have to be careful. When you multiply with minus 1, the symbol, okay, the inequality also will change. Here we had greater than or equal to. Okay, after solving, after multiplying it with minus 1, we will have less than or equal to. Okay, it will reverse. Okay, whatever we had over here, we will have the opposite one over here. Okay, is it clear? Okay, so the first one, when you are checking an LPP, the first one you have to check is if it is a minimization problem. If it is a minimization problem, we have to convert it into a maximization problem by multiplying with negative 1. Okay, second, what you have to check is, you have to check if the right hand side of the constraints is a negative number. Okay, if it is a negative number, if the right hand side of the constraint is a negative number, then you have to convert it into a positive number. How do we do that? By multiplying both sides with negative 1. Okay, is it clear? These are the first two steps that you have to take care. Okay. So I'll take you to the question now. Okay, and then I will explain the steps one by one. Okay, see over here. This is our problem. Okay, in this case, can you read the question? Use simplex method to solve the LPP. Maximize z is equal to 3x1 plus 5x2 plus 4x3. Okay, this is our maximization objective. In this case, we don't have to convert it into any other type because it is already a maximization type. It is not a minimization type. It is maximization itself. So you don't have to worry. Okay. Next step is you have to check whether these are the constraints. These three are the constraints. You have to check if the right hand side is negative number or not. Is it a negative number? Is there any negative number on the right hand side? Somebody tell me no. There is no negative number on the right hand side. So you don't have to worry. Okay. So again, we have to go into the next step. Okay. Next step is we have to introduce. Can you see here? Can you see that? Second step. Convert constraints into equations by introducing non-negative slack variables. Okay, I'll tell you how to do that. In the case of graphical method, what did you do? You just changed the inequality into equal to sign and then you took the points and then plotted on the graph, right? You did not have to do any other steps. Okay, but in our case, simplex method, you have to introduce slack variables. Okay, only after introducing slack variables, you can change these inequality symbols. Okay, so I will show you how to do that. So we'll start the answer. Okay, introduce. Non-negative slack variables. Okay, how many inequalities are there? How many inequalities? 1, 2, 3. Okay, so I have to introduce 3 slack variables. Okay, I am introducing S1, S2, S3. Okay, to convert given LPP to standard form. Okay, is it clear till now? Okay, I'm going to introduce 3 variables. Okay, these are called as the slack variables. Okay, so my maximization equation will become, so first of all, I'll write the constraints, subject to constraints. What were my constraints? The first one was 2x1 plus 3x2 instead of less than or equal to. I'm changing the inequality by adding a slack variable, that is first slack variable S1. Okay, I'm adding S1 here is equal to, the constant is 8. Okay, next one 2x2. See over here it is x2. Okay, be careful. The first variable does not start with x1, it is starting with x2. Okay, 2x2 plus 5x3. Again, we have an inequality here, less than or equal to. So I'm adding the slack variable plus S1, S2. Okay, is equal to 10. Okay, this is the first equation. This is the second equation. And this is the third one. 3x1 plus 2x2 plus 4x3 plus. Okay, again I have a inequality over here, less than or equal to. So instead of that, to change it into an equation equal to, I have to introduce a slack variable. Our slack variable is S3. Okay, see, first one we introduced S1, second equation we are introducing S2, third one we are introducing S3. Okay, S3 is equal to 50. Okay, is that clear till now? That is our third equation. Okay, we have introduced 3 slack variables, right? So we have to introduce these slack variables to the objective function also. Okay, so what is our objective function? Maximize z is equal to 3x1 plus 5x2 plus 4x3 plus S1. Okay, the objective function should not change, but I have to introduce the slack variables. How do we do that? 0 S1 plus second equation we have slack variable S2. Okay, so I'm adding 0 S2 plus third equation I have slack variable S3. Okay, so it is 0 S3. Is it clear? This is how we rewrite the LPP model. Okay, so for solving the simplex problem, okay, if we have the negative, the less than or equal to, okay, less than or equal to, we have to introduce slack variables. Only then we can convert it into equations. Okay, one more thing to remember is, initially we had told, right, in the steps, below steps to be followed when all constraints are less than or equal to type. Okay, in our problem, all the constraints are less than or equal to type. That is why we are following the below steps. Okay, if any of the constraints is greater than or equal to, or if any of the constraints is equal to, then we follow a different method. Okay, that we'll see in the next class. Okay, so only if the constraint is of the type less than or equal to, we will be following the below steps. Clear? Is it clear till then? Okay, and our right hand side, all are positive numbers. All the right hand side values are positive numbers, so we don't have to worry. Okay, so next what I will do is I'm going to, this is called as a simplex table. Okay, I'm going to introduce all these values into this table. Okay, I'll show you how. The first row we will have something called as CJ. CJ means these are going to be the coefficients of the objective function. Okay, can you tell me the coefficients of the objective function? This is the rewritten objective function. Can you tell me the coefficients? What are they? Coefficients means the number. Okay, variables means x1, x2, all of them are variables. Coefficients are the number there. Okay, tell me the numbers in the objective function. 3. Can somebody tell me? Yeah. 3, 5, 4. Then again 0, 0, 0. So I write over here 0, 0 and 0. Okay, that is the coefficients of the objective function. Now 3 corresponds to x1, right? So I write under 3, I will write x1. 5 corresponds to x2. So I write x2 here. 4 corresponds to x3. 0 corresponds to s1. Okay, over here 0 corresponds to s2 and the last 0 corresponds to s3. Okay, so I write it that way. Now over here I have something called as the basic variable. Okay, basic variable, it is represented as b. Okay, on this side I have the coefficient of the basic variable. Okay, coefficient of the basic variable. Okay, it is represented as cb. Okay, so basic variable, whichever is a basic variable, its coefficient will be written over here. Okay, now over here we have the solution. Okay, solution is represented as xb, and here we have the minimum ratio. Okay, this is how the simplex table will be written. Now what I do is, we have the 3 constraints here now, 1, 2, 3. I'm going to introduce these 3 constraints into this simplex table. Okay, can you tell me the coefficients? We have to write it correspondingly. See, first equation, we'll write it on the first row. Yeah, second equation on the second row, and third constraint on the third row. Okay, so x1 corresponding number over here is 2. Okay, so I write 2 here. Now x2, we have x2 here. Corresponding number over here is 3. Okay, so I write 3 here. I have x3 over here. So corresponding number. Do I have x3 in the first equation? Do I have x3 here? No. So I will put 0. Do I have s1? I have s1 in the first equation. So I'll put 1. Okay. S2, do I have S2 in the first equation? No, 0. So S2 will be 0. In the first equation, I don't have S3 also. So I'll put that also as 0. Okay. Now what is the answer for the first one? Equal to 8, right? So these are the solution for the first constraint. So this 8 I will be writing under solution. Okay. So I'm writing 8 there. Similarly, can you tell me for the second one? Is there x1? x1 in the second equation? Is there x1 here? No. So I will put 0. x2, is there x2? Yes. x2 is there, I'll put 2. x3 is there, I'll put 5. s1, is there s1 here? No, I will put 0. s2 is there, I'll put 1. Okay, coefficient of s2 is 1 and coefficient of s3 is 0. Okay, what is the solution? 10. So under solution, I will write 10. Clear? Now, again, the third equation, it is 3, 2, 4. There is no S1, I'll put 0. There is no S2, I will put 0. S3 is there with coefficient 1, I'll put 1. And the solution to the third equation, it is 50. Clear till now? Is it clear till now? Okay. This is our initial, simplex table, but it is not finished. We have to fill all these columns also. Okay. So how do we fill the basic? How do we fill the basic variable? How do we fill it? That is, do you know something called as the identity matrix? Identity matrix. So 3 cross 3 identity matrix will be like 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, 3 cross 3 identity matrix will be of this form. Okay, you will have 1 here, you will have 1 here, and you will have 1 here. Okay, this is one vertical line. Okay, sorry, this is a slanting line there. Okay, all the other numbers will be 0. Okay, this is called as 3 cross 3 identity matrix. Okay, identity matrix. You have to identify like this matrix from this table. Okay, can you tell me? Can you see a matrix over here? Can you see that identity matrix over here? Okay, this is the identity matrix. Okay, so the value that is 1 in the first row. 1 is there, corresponding variable is S1, right? S1, corresponding coefficient is 0. Okay, so in this first row, basic variable will be S1. Okay, did you understand that? S1, corresponding coefficient over here is 0, so I'll write 0 over here. Once again, I will tell. See, this is the identity matrix that we have found over here. In the second row, where do we have 1? In this identity matrix, we have 1 in the second row, right? 1. So corresponding variable there is S2. So I'll be writing S2 over here, and corresponding coefficient of S2 is 0. So next to S2, the coefficient I'll be writing it as 0 over here. Okay, fine. So I'll be writing S2 and the coefficient of S2 is 0. So I'll write 0 here. Okay, again, we have the identity matrix. Okay, this is the identity matrix. For the third row, we have 1 in this one. Okay, so the corresponding variable is S3 and the corresponding coefficient is, very good. Yeah, corresponding coefficient is 0. Okay, so I have S3 over here and 0 over here. Okay, so only in the initial simplex table, you have to check for this identity matrix and then collect the basic variables like this. Okay, after that, the basic variables will change on its own. Okay, basic variables you have to identify using this identity matrix, and the corresponding coefficients will be the coefficients that you have to write over here. Is it clear till now? Okay. The simplex method is not over, so the table is not over. Now we have something called as the ZJ. Okay, how do we calculate ZJ? Here we have CB, right? We have 3 numbers for that, 0, 0, 0. Okay, we have X1 here. We have 3 numbers for that, 2, 0, and 3. Okay, multiply each of this CB with each of X1 and add them. So how do we do that? 0 into 2 plus 0 into 0 plus 0 into 3. Okay, what will be the value? You multiply any number with 0, it will be 0. Okay, so 0 into 0, 0 into 2 is 0 plus 0 into 0, that is again 0. 0 into 3, that is again 0. Okay, so if I add all this, multiply and add each one, I will get a number that is 0. Okay, so I got the first ZJ number. Now I have to get the second one. Second one, can you tell me? Again, it is same one. I'll just rub it off. Okay, again, it will go to the second column. Okay, 0 into 3 plus 0 into 0 plus 0 into 2. What is the value? What will be the value? 0. Very good. 0. Again, for the next number, 0 into 0 plus 0 into 5 plus 0 into 4. Again, it will be 0. Similarly, 0 into 1 plus 0 into 0 plus 0 into 0. Again, it is 0. Similarly, 0 into 0 plus 0 into 1 plus 0 into 0. It becomes 0. 0 into 0 plus 0 into 0 plus 0 into 1. That is again 0. Okay, so that is how we get ZJ values. Again, for solution also, you can find the multiplied number. 0 into 8 plus 0 into 10 plus 0 into 15. What is the value? 0. Okay. Now you need to find Cj minus Zj. Okay. Cj is this value. Okay. 354000. That minus Zj. Zj you have already found over here. Okay. So 3 minus 0. What is the value? 3 minus 0. It is 3. Okay, again 5 minus 0, it is 5, 4 minus 0, it is 4, 0 minus 0, it is 0, 0 minus 0, 0, 0 minus 0, 0. Okay, now we have to check whether we have reached the optimal solution. Okay, we'll go to the steps and see what is written over there. Okay. Fourth step, test optimality using Cj minus Zj. Just now we found Cj minus Zj in the simplex table. We are going to check the optimality. Okay, optimality means what? We are going to check whether this is the final solution. Okay. The solution is not optimal if at least one Cj minus Zj is positive. Okay. If solution is not optimal, then proceed to next step. So in our case, can you tell me, have you reached the optimal solution? Cj minus Zj. Have we reached the optimal solution? To reach the optimal solution, we should not have even one Cj minus Zj value that is greater than 0. Okay, what is the meaning of that? All the Cj minus Zj values should be either 0 or it should be either negative numbers. Only then we can say it is a optimal solution. Only then we can say that this is the final simplex table. So have we reached the optimality in this case? No. Why? Because in this table Cj minus Zj we have positive values. Okay, 3, 5, 4. Okay, we have greater than 0 values. We should not get any greater than 0 value. Either it should be 0 or it should be negative number. Only then we can say this is the final table. But in our case, we have not reached the optimality condition. Okay, so what do? We'll again go and check the steps. Okay, so we'll go to step number 5. Find incoming and outgoing vector. Okay, incoming vector is the highest positive Cj minus Zj. Okay, which is the highest positive Cj minus Zj value in this? Highest positive value. Which is the highest? 5. Very good. 5 is the highest positive value. So what we do is, can you see the column corresponding to 5? Okay, did you see this much? This is called as the incoming vector. Okay, so here we have x2. So this will be called as the incoming vector. Okay, this will be called as the incoming vector because that is having the highest Cj minus Zj value. Okay, now again we'll go to the steps. Outgoing vector is the least positive. Over here it is minimum ratio. Okay, minimum ratio. So outgoing vector is the least positive minimum ratio. Okay, minimum ratio, can you see from here? Where minimum ratio we have not filled, right? Minimum ratio we have not filled. So we have to fill it. So how do we form the minimum ratio? Minimum ratio, we will obtain the minimum ratio by, here we have solution xb, right? So xb divided by, here we have the incoming vector as x2, right? So xb divided by x2, we will get the minimum ratio. Okay. Now divide and tell me 8 divided by 3. Okay, 8 divided by 3. Then we have 10 divided by 2. 10 divided by 2. Again 15 divided by 2. Okay, what is 8 divided by 3? Just check your calculator. 8 divided by 3, the answer is 2.66. Okay, 10 divided by 2, you have 5. 15 divided by 2, you have 7.5. Okay, now how will we select the outgoing vector? Outgoing vector is the least positive minimum ratio. Okay, so tell me the least positive minimum ratio in this 2.66 or 5 or 7.5, which is the least positive minimum ratio. Very good, 2.66. Okay, so 2.66, I'm putting an arrow. Okay, this vector, okay, this complete row that corresponds to 2.66. Okay, that will be called as the outgoing vector. So S2 is going to be the outgoing vector. Okay, outgoing vector. Okay, what is the meaning? In the next simplex table, S2 will go out of this simplex table. Okay, S2 will be removed. And what is written over here? Incoming vector. Incoming vector is X2. So X2 will come instead of S1 over here. Is it clear? So that is the meaning of outgoing vector and incoming vector. Which is the outgoing vector? We select it from the minimum ratio. Minimum positive number, that row will be selected as the outgoing vector. In this, S1 will go outside. Okay, along with that, the coefficient of S1 also will go outside the simplex table. Instead of that, who will come? The incoming vector will come. Incoming vector over here is X2. Who is the coefficient? 5. Okay, so over here we will have X2 and over here we will have 5 in the next simplex table. Is it clear till then? Okay, and there is one more thing. The intersection of these two, the incoming vector and the outgoing vector, the intersection is called as 3. This will be called as the key element. Okay, this entire row will be called as the key row and this will be called as the key column. Is it clear? This is the key row, This is the key, sorry, this is the key element. This is the key row. This is going to be the key column. Okay, clear? Okay, now I'll just tell you one more thing. The key row, okay, in that the key element should be made into 1 in the next simplex table. Okay, this is the initial simplex table. In the next table, we have to convert. In the key row, we have the key element, right? Key element has to be made as 1. Okay, these are all certain algorithms. Okay, you have to follow the steps as such. Okay, so in this key row, there is a key element. We have to convert this key element into 1. How can we do that? How can we convert this key element into 1? We have to divide this entire row by which value? 3. Very good. Divided by 3. Okay, so this full row I have to divide by 3. Only then I will get this as 1. Okay, if it is already 1, we don't have to make any changes to this key row. Otherwise, we have to divide each value with the key element. Okay, so that this number will become 1 in the next simplex table. Okay, I'll show you the steps in that. See, we have already found the key element. Okay, key element is the element at intersection. Okay, now perform the following operations. Okay, what are the following operations? If key element is 1, then the row will remain the same. Okay, if key element is other than 1, then divide each element in key row, including our solution. Okay, XB with the key element. Okay, so these are the operations that we have to do. Key row, new key row, that is key row new, okay, will become key row old divided by key element. Okay, key element is, in our case, which one? 3. Okay, so each number in the key row we have to divide by 3. Okay, next one. Any other rows? We have other rows now. Instead other than key row, we have 2 more rows, right? What should we do to the other 2 rows? Okay, row, sorry, it is not old here, it is new. Okay, so row new will become, how it will change? Row old minus number above or below the key element into corresponding number in the key row. Okay, key row, which is the new one. Okay, I'll show you how it will become. Okay, this is R old minus number above or below the key element. Suppose I am considering row 1 here. Okay, just imagine I am considering. Okay, in our case, suppose I'm considering row 2 here. Okay, I'm putting R2 here. Okay, R2, how will it will change? R2 new is equal to R2 old. Okay, R2 old. What are the values of row 2? 0, 2, 5, 0, 1, 0 and 10. These are the numbers in the row 2. Okay, these each number, it is going to change. How it will change? R2 old minus number above or below the key element. Which is the key element in this case? Our key element is 3. Okay, 3 is our key element that we have found out. Key is our 3 is our key element. Okay, number above or below the key element means we are considering the second row now, which is the number corresponding to the key element when we are considering the second row. Very good, 2. Okay, if I am considering the third row, which is the number above or below the key element, 2. In this case, this 2. Okay, so you have to be very careful. When I'm talking about the second row, the number, the key element, okay, over here, the number above or below the key element, okay, that number will be this 2. Okay, this 2. Okay, above we don't have to consider because we are considering only the second row. Now, if I'm considering the third row, okay, which is the number above or below the key element, which number we have to take? We have to take this 2. Okay, is it clear? Okay, till then we'll solve it, and then we have one more number, that is corresponding number in the key row new. Okay, key row new means we have already changed the new key row as this operation, right? Okay, we have got a new row for the key row. Okay, that row number will be taken over here. You don't have to worry. we'll solve the problem and then you will understand. Okay, so we'll solve the problem. Okay, till now we have got this much. Okay, we have got this simplex table. Okay, now we are going to do the row operations. Okay. We'll solve the row operations there. Okay, tell me the key row. What will happen to the key row? Key row new. How is it going to change? I already told you in the key row, the key element should become 1. Right? In the new simplex table, key element should become 1. For that, what should I do? Key row new is equal to key row old. Tell me somebody. Divided by 3. Okay. If I'm dividing 3 divided by 3, it will become 1, right? That is why we are performing this operation. Okay. Now tell me what are the elements in the key row? What are the elements in the key row? 2, 3, 0, 1, 0, 0 and 8. These are the numbers in the key row. Okay. I'm going to divide each of these numbers with 3. Okay. 2 divided by 3, 3 divided by 3, 0 divided by 3, 1 divided by 3. Okay. Again, 0 divided by 3, 0 divided by 3 and 8 divided by 3. Okay, can you tell me the answer? In this case, I'll put it as 2 divided by 3 itself. Here it becomes 1. Okay, 0 divided by 3 is 0. Here I'm keeping it as 1 by 3 itself. 0 divided by 3 it is 0. 0 divided by 3 it is 0. Here I'm keeping it as 8 by 3 itself. Okay, next one. So key row, this is now our new, see, this will be our key row new. Okay, understood till this? Did you understand? Okay. Next one. Yes, okay. Next one, I'm going to take the second row from there. Second row is, can you tell me the numbers? My finger is pointing here. This is the second row till this one. Okay. Yeah, you have to tell me the numbers. Right. We have the, this is called as R2. This is R2, okay. See, this is R1. Okay, this is R2. This is R3, row 3. Okay, so how will the numbers change? R2, can you see? R2 new is equal to R2 old minus, okay, we told number above or below the key element. Okay, according to R2, this is R2, number above or below the key element means this is the key element, number below it is 2. Okay, so my formula will change as 2 multiplied by, okay, what is written in the steps there? Number above or below the key element multiplied by corresponding number in the key row new. Okay, you have to be very careful. It is key row new. Okay, so I'm writing it. Multiplied by key row new. Okay, now tell me, from this you will check and tell me what is R2 old. R2 this one. R2 old is also same thing only. Tell me the numbers. 0, then 2, then 5, 0, 1, 0 and 10. Okay. You see, I have taken down the numbers in the R2. Okay, R2 old including the solution number. Solution number was 10. Okay, solution also I have taken it down. Okay, R2 old minus. Okay, the easy method is just put minus everywhere. Okay. Then I have a bracket here now. Put the bracket here. Okay, then multiply by 2. This is the number above or below the key element corresponding to the second row. Okay, so I have 2 multiplied by 2. Okay, into, okay, key row new. Okay, which is our key row new? Don't go back to the simplex table. Previous simplex table, you have to take key row new. Okay, key row new is 2 by 3, 1, 0, all these numbers. Okay, so I'm writing it down. 2 by 3, I'm writing here 2 by 3. Then I have 1. Okay. 2 by 3. I'm writing here 1. Again, you have on top 0, 1 by 3, 0, 0. So I'm writing 0, 1 by 3, 0, 0. And the last number here is 8 by 3. I'm writing it as 8 by 3 here. Okay. Once you get familiarized with these steps, you can do it very fast. Okay. Because it's the first time, it will take some time for you. Okay. So 0 minus 2 into 2 by 3. What's the value? 0 minus, that is value will be minus 2 into 2 is 4. 4 by 3. Okay, next one. 2 minus 2. What will be the value? 0. 5 minus 2 into 0. So 2 into 0 you have to solve first. That is 2 into 0 is 0. 5 minus 0 is 5. Okay, then again 0 minus 2 into 1 by 3. Okay, so the value is minus 2 by 3. Next one, 1 minus 2 into 0. 2 into 0 you have to solve first. 2 into 0 is 0. 1 minus 0 is 1. Okay, don't write 0 there. Okay, next one, 0 minus 2 into 0. 2 into 0 is 0. 0 minus 0, 0. Next one, 10 minus 2 into 8 by 3. Okay, 10 minus 2 into 8 is 2 into 8 is 60 divided by 3. Okay, how do you solve this? How do we solve this? We have to take the LCM and solve it. How do we do that? 3 into 10, that is 30 minus 16 whole divided by 3. Okay, it will become 14 divided by 3. Okay, 14 divided by 3. There is an easy method for solving fractions. Okay, using your calculator. Okay, what is the method? Just take your calculator. Okay, can you see one thing over here? One block divided by another small block here. You can see that, right? This one. Okay, using this we can solve fractions. Okay, how do we do that? Here I have 10 minus 16 by 3. Okay, so I'm putting 10 minus, okay, 16 by 3 is one digit, no? So I have to put bracket, otherwise sometimes we'll go wrong. So 10 minus, I'm opening a bracket. Okay, I have 16 divided by 3. So I'm writing 16. Then I'm pressing on this block. Okay, on this block. I press on it and then divided by 3 here, right? So I write 3 and I close the bracket. 16 by 3 is one number. So I am closing 16 by 3. I have written over here. So I'm closing the bracket. Okay. Now I press it. I get 14 divided by 3. See, 14 divided by 3 is already what we got. So you don't have to go and take any LCM or anything. Everything is there in this calculator itself. Okay. So by calculator also we can get the same method. Okay. For example, I'm taking, see, 4 by 3 minus 2 by 5. Okay. For solving such problems, you have to take the LCM. Okay. How do we take it? 4 into 5 minus 2 into 3 divided by 3 into 5. You will have to solve all these problems. It is little difficult. So you directly take your calculator. Okay, put a bracket. This is one. Take this as one number. Take this as the other number. You have to put proper brackets. Okay. So what do we do? Put a bracket. Press 4. Then it is divided by, no. So instead of that, instead of divided by, you click this block number. Okay, this number. I pressed that, divided by 3, close the bracket, minus, again open the bracket. I have 2 divided by 5. Okay, close the bracket, press equal to, you will get 14 divided by 15. So instead of doing all this process, just put on the calculator, you will get 14 by 15. Okay, is it clear? Okay, this way you have to do when you need the answer in fractions, like 14 divided by 15. Okay, if you want the answer in fractions, you have to take this button. Okay, otherwise, if you need correct 14 divided by 15 in our usual sense, no, we do 14 divided by 15. For getting that, you will have to press the division button. Okay, so in our case, over here we need fractions. That is why we pressed this block button. Okay, clear? Okay. So just I wanted to explain that. So this is our new key 2. Okay, row 2 new. These will be the values. Next, we need to find 1 4, right? There is R3 also. Okay, we have to find the values for R3. Okay, Tell me the numbers in R3. R3 new is equal to R3 old minus, which is a number corresponding to the key number. Here it is this 2. Okay. So 2 into the R, which is the key row. Okay. That is the key row new. Okay. Now tell me R3 old is equal to these. This one is what the values you have to tell. R3 old. Can you tell from this very fast? 3. Okay. Then 2, 4, 0, 0, 1 and 15. Okay. Till 15 you have to write, including the solution. Okay. Minus. I have a minus here now. So I'm putting minus everywhere. Okay. Then I have a bracket. Open the bracket. Okay. Then I have 2 into. Okay, then I have key row new. Don't go to the simplex table. This is not the key new row. Okay, this is not the new row. New row we have already found out, right? See, this is the new row. Okay, so tell me the numbers. 2 by 3, 1. Okay, 2 by 3, 1, then 0. Then I have 1 by 3. Then I have again 0, then 0, and then 8 divided by 3. Okay, I have written over here. Okay, now tell me quickly the answers. This is equal to 3 minus 4 by 3. Okay, don't have to check the LCM. Go to your calculator. It is 3 minus, put a bracket, 4 divided by 3. Okay, which is equal to 5 divided by 3. Okay, I get the answer there. Can you see it? 5 divided by 3. Okay, next one. 2 minus 2, that is 0. Again, 4 minus 2 into 0. 2 into 0 is 0. So 4 minus 0, it is 4. Again, 0 minus 2 by 3. That is minus 2 by 3. Here 0 minus 2 into 0. 2 into 0 is 0. So 0 minus 0, it is 0. Then again, 1 minus 2 into 0. 1 minus 0, that is 1. Again, over here we have 15 minus 2 into 8 is 16 divided by 3. Okay, go to your calculator. 15 minus, put a bracket, 16 divided by 3. Okay, you will get, no, sorry, you should not put this divide. Okay, I'm sorry, I made a mistake. It is 15 minus, open the bracket, 16, go to this divide. Okay, divided by 3. Put the bracket close. Okay, you get 29 divided by 3. Okay, is it clear till now for everyone? Okay, with these values, I'm going to draw the first iteration table. Okay, these are the values. I'm going to draw the first iteration table. Okay, here again, we are going to repeat the same. Cj, the coefficients of Cj will remain the same, right? Objective functions coefficients are not getting any change. Okay, so Cj will remain the same. Tell me 3, 5, 4, 0, 0, 0. Okay, 3, 5, 4, 0, 0, and 0. Okay, what were the variables corresponding to 3, 5, 4, 0, 0, 0? It is x1, x2, x3, s1, s2, s3. Okay, so it is x1, x2, x3. Can you see? S1, S2, S3. Over here we have basic variable. Okay, basic variable that is represented by B. Here we have the coefficient of B. Here we have the solution that is represented as XB. Here we have the minimum ratio. Okay, and then over here we are going to write the new values. Okay, we had already told, do you remember that this is the outgoing vector and this is the incoming vector, correct? No? So instead of S1, I will be writing x2. Instead of 0, I will be writing the coefficient of x2, that is 5. Okay, clear? So I'm writing x2 instead of S1. Okay, and the coefficient of x2 is 5. So I write 5 here. The rest of the values will remain the same. So 0 S2, 0 S2, and 0 S3. 0 S3. Okay, this is actually not complex. This is only a lengthy process. Okay, so don't get worried. Second time onwards, you will find it easy. Okay. Till then, we have done. Now we have to get the values of R1, R2, and R3. New values of R1, R2, and R3. Our key row, that is this one. These are the new values. Okay, can you see these are the new values? I'm going to write the new values. Can you tell me the values? It is 2 by 3, 1, 0, 1 by 3, 0, 0, and 8 by 3. Okay, next one, R2 new is this one. So I'm going to write these values. Minus, tell me the values. Minus 4 by 3, 0, 5, minus 2 by 3, 1, 0, and it is 14 divided by 3. Okay, now we have R3 new. Okay, R3 new, write down the values. It is 5 by 3, 0, 4, minus 2 by 3, 0, 1, and 29 divided by 3. Okay, we got it till then. Yeah, all the values are correct. Okay, now what do we do? What is the next step we do? Can somebody tell me? After writing till this much, what do we do? നമ്മൾ എന്താ ചെയ്യാറ്? ഇത്ര എഴുതി കഴിഞ്ഞാൽ നമ്മൾ എന്താ ചെയ്യണേ? We have to calculate ZJ, right? We have to calculate. Very good. We have to calculate ZJ. ZJ, how do we do? We have to multiply this column with each of these columns and then add those values. Okay, quickly tell me 5 into 2 by 3 plus 0 into minus 4 by 3 plus, okay, should I write it down? Okay, this value. This value. Okay, how will I write it? 5 into 2 by 3 plus 0 into minus 0 into minus 4 by 3 plus 0 into 5 by 3. Sorry, 0 into 5 by 3. What will be the value? Is going to be? Tell me. This is 0, this is 0, this is 10 by 3. Okay, so I write the value here, 10 by 3. Again, similarly, you tell me 5 into 1 plus 0 into 0 plus 0 into 0, I get 5. Then again, 5 into 0, that is 0, 0 into 5, that is 0, 0 into 4, that is 0. So together I get 0. Again, 5 into 1 by 3 plus 0 into this number is 0, 0 into this number is 0. So just we have to take 5 into 1 by 3, that is 5 by 3. Very good. Next one, 5 into 0, 0, 0 into 0, 0, sorry, 0 into 1 is also 0, 0 into 0, again 0. In any case, we have 1 0, so full number becomes 0. Again, this one, 5 into 0, 0, 0 into 0, 0, 0 into 1, we get 0. Okay, again, 5 into 8 by 3 plus 0 into this number, 0, 0 into this number, 0. So we get 5 into 8 by 3, that is 40 by 3. Okay, 40 by 3. Next, what do we do? Next step, we have to calculate Zj minus Zj. See, this is the same repetition. Okay, everywhere you are going to repeat the same steps. There is no change. Okay, Cj minus Zj, this is our Cj value. Okay, 3, 5, 4, 0, 0, 0. These are the Cj values. You have to subtract each of this to this one. Okay, so over here, this value will become 3 minus 10 by 3. Okay, 3 minus 10 by 3, go to your calculator. Okay, 3 minus 10, can you see? 10 divided by 3, okay, which is equal to minus 1 by 3. Minus 1 by 3. Again, 5 minus 5, 0. 4 minus 0, 4. 0 minus 5 by 3, it is minus 5 by 3. 0 minus 0 is 0. 0 minus 0 is 0. Okay, you got Zj, Cj minus Zj. Okay, can you tell me, is this an optimal answer? Is this optimal? For optimality, what should we have? All Cj minus Zj value should be less than or equal to 0. This is the optimality condition. Okay, this is the optimality condition. Okay, can you tell me? In our case, from the simplex table. Yeah, very good. Here, all the values are not negative or 0. We have one value, that is 4, which is a positive value. Okay, so this will become our, which value? Incoming vector or outgoing vector? This will become our outgoing vector. Okay, now we need to select which is going to be the, sorry, this is going to be the incoming vector. I don't know what I said. Okay, so this is going to be the incoming vector. We need to select which is going to be the outgoing vector. How do we do that? We have to calculate the minimum ratio. Okay, minimum ratio, how do we do? XB divided by, XB is solution column. Okay, XB divided by the key column. Key column, or this is also called as the incoming vector, that is X3. Okay, so divide and tell me. 8 by 3 divided by 0. 8 by 3 into 0. Any number, can you divide it by 0? It is not 0. We cannot do that. You cannot divide a number with 0. Okay. You can divide a number. You can divide 0 with some other number. But you cannot divide any number with 0. That is not defined. Okay. So I'll put a dash here. I cannot do that. Okay. Next one. 14 by 3 divided by 5. Instead of divided by 5, I can write multiplied by 5 in the denominator. Okay. So 14 divided by 15. What is the value? 14 divided by 15 is 0.93. Okay. Again, 29 divided by 3. Instead of writing divide, I am writing multiplied by 4 in the denominator. What is the value? 29 divided by 12. 29 divided by 12 is, I'm doing in the calculator, okay, 2.41. Okay, so yeah. What's the value there? Somebody wrote a value there. Yeah, okay. Yeah, over here we have 2.41. So, which is the least positive number in this? 0.93 or 2.41? Least positive number. Least positive number is 0.93. So, that is going to be the incoming vector. So, S2 is going to be the incoming vector. Here, incoming vector. Which is our key element here? Key element. Key element. Which is our key element? See, I'm sorry, I'm not giving a break. Okay. Yeah. Yeah. I'm sorry, I'm not giving a break. I'll complete this problem and then I'll leave you for the day. Okay. So, key element over here is 5. Okay. Key element is the intersection value, that is 5. Okay. In this case, S2 is going to be the outgoing vector. It will go out of the table. Okay. X3 is going to be the incoming variable. Okay. Now we have the row operations. We should do the row operations. Can you tell me the row operations? By now you must be knowing the row operations, right? What will be the row operations? Key row, how will it change? Key row, how will it change? Tell me. Key row, that means key row means it is second row, right? That is a key row. R2 new is equal to R2 old divided by which number? Which number should I divide the key row? Very good, 5. Because this is the key row, this is the key element. Okay, in the next simplex table, instead of 5, I should get 1. Okay, for getting 1, I will divide this number with the same number. Okay, so it is not enough that I divide only this number. I have to divide each of the numbers in the key row with the key element. Okay, that is why over here we have the equation like that. R2 old divided by 5. Okay, now tell me the numbers of R2 old. R2 old is minus 4 by 3, then 0, then 5, minus 2 by 3, 1, 0 and 14 by 3. Okay, I'm multiplying, divided by 5 means same, you didn't see, right? These are the numbers that I've taken down. Okay, these are the old values of R2, okay, from the previous table. Okay, into divided by 5. So I am writing 1 by 5. Okay, is it clear? Now here also I am writing 1 by 5 into 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 1 by 5. Okay, is it clear? Okay, minus 4. What will be the value? Minus 4 by 3 into 5 is minus 4 by 15. Okay, 0 into any number, it is 0. Here 5 and 5 cancel, you will get 1. Here you will get minus 2 by 15. Here you will get 1 by 5. Here 0 into any number, that is going to be 0. Here you will get 14 by 15. Okay, that is going to be the our R2 new. See, second row was the key row. Okay, we have changed all the key row, old values of key row into new values. These are going to be the new values. Okay, is it clear? Just give me a second. Okay, minus 4 by 15, 0, 1, minus 2 by 15, 1 by 5, 0, and 14 by 5. Okay, all the values are correct. Now we need to change the R1. Okay, we have changed only R2 now. Okay, this is R2, this is R1, this is R3. We have changed only R2 here. Now we need to change R1. How do we change R1? Tell me the steps. R1 new is equal to R1 old minus number above or below the key element. Okay, we are considering row 1, number above or below the key element. Which is the element? Which is the element? Check this table and tell me. Say we are considering the first row here. That is why we have written R1 new. R1 new is going to become as the following. Yeah, R1 old minus number above or below the key element. Since we are considering the first row here, it should be the number above the key element, which is 0. Okay, 0 into, then we have new key row. Okay, that is R1 new. R1 new is our new key row. Okay, this is the same as key row new. Okay, the previous step we found this value now. Okay, so quickly tell me R1 old, all the values. Tell me the values. R1 old means it is 2 by 3, 1, 0, 1 by 3, 0, 0, and 8 by 3. I am writing it down. 2 by 3, 1, 0, 1 by 3, 0, 0, and 8 divided by 3 minus. Okay, can you see that? Okay, then 0 multiplied by 0. I am writing this. Okay, 0, 0, 0 multiplied by, okay, R1 new. Okay, it is R1 new. Okay. Now you tell me any number multiplied by 0. Will there be any effect? Okay, so I'm not going to actually find out what is R1 new. I'm not going to take down anything. Okay, what I'm going to do is, you already know, right? The values will be the same because any number multiplied by 0, it is going to be the same. It is going to be 2 by 3 itself. So R1 new is actually going to be R1 old itself. There is no change because any number multiplied by 0, this whole thing is going to be 0. So there is no effect. This in effect is same as R1 old itself. Okay. So I'm writing the same number seen over here also. 2 by 3. It is 1, it is 0, it is 1 by 3, it is 0, it is 0, and it is 8 by 3. Okay, there is no change. Quickly tell me R3 new. What happens to R3 new? Tell me R3 new's values. R3 new will be, this is R3 new. R3 new will be, okay, R3 new will be R3 old minus number above or below the key element. Which element should I consider over here? This is the R3 new. Okay, sorry, R3. This is the old values of R3. Number above or below the key element. Okay, the number, very good. Number is going to be 4. Okay, since we are considering the third row, okay, the number which is below the key element is our concern. Okay, so here it is 4. Okay, so I'm taking down 4 multiplied by the new key row. New key row is the second row. Okay, so key row, yes, key row new. Okay, key row new. Okay, tell me R3's old values. Tell me the old values. It is 5 by 3. Yeah, 0, 4. 0, 4 minus 2 by 3. 0, 1 and 29 by 3. Okay, 0, 1 and 29 by 3. Okay, minus this minus, okay, bracket 4 multiplied by. Okay, so minus 4 multiplied by, I'm writing it down for every number. Okay, Okay, now it is key row new. Okay, key row new we have already found out. See, R2 new, this is also R2 new, it's the same as key row. Key row new. Okay, it's the same thing. Okay, so tell me the values there. Minus 4 by 15, minus 4 by 15, 0, 1. So I'm writing over here. Minus 4 by 15, 0, 1. Then what are the other values? Minus 2 by 15, 1 by 5. Minus 2 by 15, 1 by 5. Then 0 and 14 by 5. 0 and 14 by 5. Okay. Solve it and tell me first. This number is not there. Okay. Okay, what will be the value here? 5 by 3. Here minus and minus. It will become plus. Okay. Plus 4 into 4, it is 16 divided by 15. What is the value? Take a calculator and find it out. 5 divided by 3 plus, put a bracket. Okay, this is one digit, no? So 16 divided by 5, put it in bracket so that you will not make any mistake. Okay, value is 41 divided by 15. Okay. Yeah, 41 divided by 15. Okay. Next one. 0 minus 4 into 0. 4 into 0, 0. 0 minus 0, 0. Now next one. 4 minus 4, that is 0. Then minus 2 by 3. Here minus and minus you will have plus. Okay. 4 into 2, 8 divided by 15. Take out a calculator and find it out. Okay. Minus 2 divided by 3. Here plus, bracket open. Can you see the calculator? Bracket open, 8 divided by 15. 8 divided by 15. Okay, which is equal to minus 2 divided by 15. Minus 2 divided by 15. Again, here minus 4 divided by 5. Here 1 minus 4 into 0. That is 1 minus 0. It is 1. Here 29 divided by 3 minus 4 into 14 divided by 5. Okay, 4 into 14 is 56. 56 divided by 5. Do it in the calculator. 29 divided by 3 minus 56 divided by 5. Okay, what is the value? Minus 23 divided by 15. Okay, just one second. Just once again, give me a second. Okay, sorry, here it is 14 divided by 15. Okay, the key row's value is, I made a mistake. See, it is 14 divided by 15. Okay, so you have to write here 14 divided by 15. Okay, so my value went wrong. Here it is 56 divided by 15. Okay, so it is 29 divided by 3. Okay, minus, bracket open, 56 divided by 15. Okay, so you will get 89 divided by 15. 89 divided by 15 is the correct answer. 89 divided by 15. Okay, so you got all the values of R1, R2 and R3. Substitute it in the new simplex table. Okay, I have already drawn the new simplex table over here. Can you tell me quickly what is going to be the values of Cj? Cj will not change. Okay, the objective functions coefficients will not change. I already have a table here. See, Cj will not change. I'm going to just put all those values there. Okay. Tell me what are the coefficients of Cj? It is 3, 5, 4, 0, 0 and 0. What are the variables? X1, X2, x3, s1, s2 and s3. Okay, this is our basic variable b. This is the coefficient of the basic variable, that is cb. Okay, now this is our solution. It is represented by xp. This is the minimum ratio. Okay, minimum ratio. Then we have the outgoing vector and the incoming vector. Okay, so take the simplex table and see the outgoing and the incoming vector. Can you see the simplex table here? This is our previous simplex table. Which value should go and which value should come? Can somebody tell me? In the second row, S2 should go. S2 should go, and instead of that, we should have X3. So I'm writing X3 here. Okay, I'm writing X3, which is the coefficient of X3? 4. So 4 will come out here. Okay, other values will remain the same. X2 and 5 will remain the same. So I'm writing here X2 and 5. Okay, now S3 and 0 will also remain the same. Okay, S3 and 0 will also remain the same. Fill up all the other values using our new values. Okay, R1 new. See, this is R1 new. Take down these values and write as the first row. Okay, 2 by 3, 1, 0. 2 by 3, 1, 0. 1 by 3, 0, 0, 8 by 3. 1 by 3, 0, 0 and 8 by 3. Okay, now next one, which is R2. R2, can you see here? R2, it is also our key row new. Okay, take down the values and write. What are the values? Minus 4 by 15. Okay, minus 4 by 15. Then 0, 1 minus 2 by 5. Can you see that? 0, 1 minus 2 by 5. Minus 2 by 15. So it is 2 by 15. Then 1 by 5. I'm writing 1 by 5. Okay. Then 0 and 14 by 15. 0 and 14 by 15. Okay. That is R2 new. That is R2 new. Next we need to get the values of R3 new. Okay. R3 new is these values. Tell me the values. 41 by 15. Okay. 41 by 15. Then 0, 0 minus 2 by 15. 0, 0 minus 2 by 15. Then minus 4 by 5, 1. 4 by 5, 1. And last value is 89 divided by 15. 89 divided by 15. Okay. Okay, now what do we do? What is our next step? We have to test for, tell me, we have to test for optimality. Okay, how do we test for optimality? We have to calculate Cj minus Zj. Okay, so before that, we have to calculate the values of Zj. How do we calculate Zj? All these column numbers have to be multiplied with each of these columns. Okay, quickly tell me. Can you tell me the values? 5 into 2 by 3. Okay, 5 into, I am writing it on top. Okay, 5 into 2 by 3 plus 4 into minus 4 by 15 plus 0 into 41 by, can you see 0 into 41 by 15? That is of no use. So I am putting 0. That is 10 by 3 minus, see over here minus is there. So minus 16 divided by 15. What is the value? 10 by 3 minus, put a bracket open, 16 divided by 15. Okay, what is the value? I get 34 divided by 15. Okay, so I'm writing this is 34 divided by 15. I'll just for your, okay, so our answer is 34 divided by 15. Okay, quickly tell me the other values. 5 into 1 plus 4 into 0 plus 0 into 0 is 0. So it is only 5 into 1, that is 5. Next one, 5 into 0, 0, 4 into 1, 4, 0 into 0, 0. So it is only 4. Next one, 5 into 1 by 3. So that also we will, I will write it down and show it to you, this value. Okay. Tell me what will be the values? 5 into 1 by 3. Okay. 5 into 1 by 3 plus 4 into this 4 into minus 2 by 15. Okay. Minus 2 by 15. That is 5 by 3 minus 8 by 15. What is the value? 5 divided by 3 minus 8 divided by 15, which is 17 divided by 15. Okay. 17 divided by 15. Again, here it is 5 into 0 plus 4 into 1 by 5 plus 0 into minus 4 by 5. That is 4 into 1 by 5. That is 4 by 5 alone. Over here, 5 into 0 plus 4 into 0 plus 0 into 0. Again, that you will get it as 0. Okay, this one. These numbers multiplied by these numbers, you get 0. Again, you need to find this one. Okay, over here, this value. So, I am taking over here 5 into 8 by 3. 5 into 8 by 3 plus 4 into 14 by 15. 14 by 15 plus 0 into 89 by 15, no use, so I am writing it as 0. Okay, here I have 5 into 8 by 3, that is 40 divided by 3 plus 14 into 4. How much is 14 into 4? I have 56 divided by 15. Okay, go to the calculator and find out the answer. 40 divided by 3 plus 56 divided by 15, which is equal to 256. I hope I have not made a mistake. Yeah. 256 divided by 15. Okay, the value is 256 divided by 15. Okay, that is Zj. Now for checking optimality, we should have Cj minus Zj. Okay, Cj value is this one, Zj value is this one. You have to subtract both of it. 3 minus 34 by 15. Do it in your calculator. 3 minus 34 by 15. Okay. 34 divided by 15, that is equal to 11 divided by 5. Okay. Sorry, 11 divided by 15. Next one, 5 minus 5, that is 0. 4 minus 4, it is 0. 0 minus 17 by 15, that is minus 17 by 15. 0 minus 4 by 5, that is minus 4 by 5. 0 minus 0 is 0. Okay. Can you tell me, have you reached the optimality condition? Somebody please check and tell me. Have you reached the optimality condition? Optimality, you have to check the Cj minus Zj value. Have you reached the optimality condition? Yes? Have you reached it?
No.
No, we have not reached. Why?
11 by 15 positive number.
11 by 15 is still a positive value. So what we should do? We have to again repeat the same procedure. Okay. So don't worry, I will do it very fast. Okay. So this is going to be our incoming vector. Okay. X1. This one is going to be the incoming vector. We need to find the outgoing vector. For that we have to do the minimum ratio. Okay. Minimum ratio, how will you do? XB divided by XB is this one. XB divided by X1. X1 is the incoming vector, or it is also called as the key column. Okay, so divided by x1. Okay, tell me this. 8 divided by 3. Instead of doing this, how can I do it? How can I do the division? 2 by 3 I'm going to divide it multiplied by the reverse. No, so it is 3 by 2. Okay, 2 by 3 will become multiplied by 3 by 2 when I do the division. Okay, so it will become 3 and 3 cancel. It will become 8 by 2. Okay, next one. 14 divided by 5. Sorry, 15 multiplied by minus 4 divided by 15. It will reverse when we do the division. It will become minus 15 divided by 4. What is the value? 15 and 15 goes cancel. It will become minus 14 divided by 4. Okay. Now next one, 89. 89 divided by 15 multiplied by 15 divided by 41. Okay. 15 divided by 41. 15 and 15 cancelled. I will get 89 divided by 15. Okay, which is the smallest value in this? For selecting the outgoing vector, we have to select the smallest value from this. Which is the smallest value?
Ma'am, 89 by 41.
Sorry, did I do wrong?
The main
Sorry. Okay. 41. Sorry. 41. Okay. 89 divided by 41. Is the smallest value?
Minus 14 by 4.
Minus 14 by 4. Ara parnala Roshan. Okay, see, how do we select the minimum ratio? How do we select the minimum ratio? Yeah, this is the minimum ratio. Okay, outgoing vector is selected as the least positive minimum ratio. Okay, so you have to consider only positive values. If we have the minimum ratio is negative, we will not consider that. Okay, so now you tell me. So here I am putting a blank. We should not select this negative number. Okay, only positive numbers we have to consider. So which is the smallest positive number? Here it will be 4, and here it will be 89 divided by 41. What is the value? 89 divided by 41 means it is going to be 2.17. So which is the smallest number? Smallest number is smallest number. 2 point. Smallest number is compared with 4. We have to select the least positive number. Okay, positive number is the least in that is this one. Okay, so this last row is going to be the outgoing vector. Okay, so I'm going to select the last row. Okay, quickly tell me which is the key element. Which is the key element? Key element? Key element is? Key element? How do we check the key element?
41 by 15.
Yeah, 41 by 15. Okay, the intersection of the two vectors are called as the key element. Okay, so in the next simplex table, instead of S3, who will come? X1 will take the place, and instead of 0, the coefficient of X1 is 3. So X3 3 will take the place of 0. Okay, quickly tell me the row operations. How will we have to start from the key row? Okay, always start from the key row. Key row is R3. No, so R3, how is it going to change?
Key element 1 ആവുന്നവരെ ചെയ്യണോ?
വേണ്ട, key element 1 ആവുന്നവരല്ലല്ലോ. നമ്മുടെ ഓപ്പറേഷൻ എപ്പോഴും Cj minus Zj value ആണ് നമ്മൾ നോക്കുന്നത്. The optimality is we check the Cj minus Zj value. Okay. Until this, all the numbers over here is either 0 or less than 0. Okay, negative number അല്ലെങ്കിൽ 0. Till then, we have to continue this process. Okay, don't worry. Within one more table, within the next table, it will be over. Okay, so don't worry. Quickly tell me the operation. What is that, Roshan?
അല്ല ഇത് ഈ സിംപ്ലസ് ഈ തരത്തിലുള്ള ചോദ്യങ്ങൾക്ക് ഇത്ര ടേബിൾസ് എന്തായാലും വരയ്ക്കേണ്ടി വരുമോ?
Usually they will give the question only with 3 tables. Okay, so first table, that is the initial table, therein you are not calculating anything, just writing down the values. Second one is the first iteration. പിന്നെ ഒരു iteration കൂടെ ഉണ്ടാവും. ഇത് ഞാൻ ഇത്ര ഒരു വലിയ പ്രോബ്ലം എടുത്തത് നിങ്ങൾക്ക് ഒന്നുകൂടെ ഒന്ന് മനസ്സിലാവാൻ വേണ്ടിയിട്ടാണ്. Okay, so that everyone is clear. പിന്നെ ഇത്ര ടഫ് പ്രോബ്ലംസ് എടുക്കുന്നതെന്ന് പറഞ്ഞാൽ സോ ദാറ്റ് ഇതിനെക്കാട്ടിലും ഒരു ഈസി പ്രോബ്ലം വരുവാണെങ്കിൽ യു ക്യാൻ സോൾവ് ഇറ്റ് ഈസിലി. ഓക്കെ, ഡോണ്ട് വറി, വിത്തിൻ വൺ മോർ ഐറ്ററേഷൻ ഇറ്റ് വിൽ ബി ഓവർ. പറഞ്ഞോ.
Cj minus Zj 0 പോസിറ്റീവ് വാല്യൂ ആണോ? നെഗറ്റീവ് വരാൻ പാടില്ലേ? അതുവരെ ചെയ്തുകൊണ്ടിരിക്കണം ഐറ്ററേഷൻ.
Till either Cj minus Zj becomes a negative value or 0. Any values. Okay, negative or 0.
പോസിറ്റീവ് വരാൻ പാടില്ല.
Positive വരാൻ പാടില്ല. Positive, if there is a positive number, we have to again do the iterations.
Okay.
Okay, so can you tell me the row operations? We have to start from the key row. Key row the operation തൊട്ട് വേണം start ചെയ്യാൻ. Okay, tell me the operations. So R3, how is it going to change? Then R1, R2, R3. This is R1, this is R2, this is R3. In our case, R3 is the key row. Okay, you have to start the operations from the key row because R2 and R1 will be built on this key row, right? They are taking values from the new key row. Okay, അതുകൊണ്ട് key row വേണം ആദ്യം ഓപ്പറേറ്റ് ചെയ്ത് നമ്മൾ new values കണ്ടുപിടിക്കാൻ. So R3, how is it going to change? R3 new, this is also called as the key row new. Okay, this is also called as the key row new. That is going to change as, tell me, R3 old divided by which value should I divide it with? Divided by 41 divided by 15. Okay, So each of the R3 values I should divide it by 41 divided by 15. So tell me the values of R3. First of all, it is 41 divided by 15. See here, 41 divided by 15. Then I have 0, 0, 0, 0, minus 2 by 15, minus 4 by 5, then 1. Then I have 89 divided by 15. Okay. Now what do? I have to divide it. Divide it by 41 by 15. On the pagaram, I can do the reverse multiplication. That is multiply by 15 by 41. Okay, I am multiplying everywhere by 15 by 41. Sorry. 41 multiplied by 15 by 41 multiplied by 15 by 41. Okay. Here all the values will get cancelled. 41 and 41 cancel, 15 and 15 cancelled 1, multiplied by 0, I get 0. Yeah, very good. Then again multiplication with 0, it is 0. Over here 15 and 15 will go cancelled. It is minus 2 by 41 here. Here it will become 3. Okay, 3 minus 4 into 3, it is minus 12 by 41. Which is 15 by 41, and this is 89 divided by 41. Okay. Yeah, correct. Now next operation is for R1. Okay, is it clear? R1. Tell me R1 value, how will it change? How will R1 change? R1 new is equal to R1 old minus number above or below the key element. Okay, this is R1 row. Okay, which number should I take? Number below the key element means which number? I am considering the first row here. So which will be the number? Number above or below the key element. Key element is 41. Okay, so which element should I consider? 2 by 3 or minus 4 by 15? 2 by 3 because I am considering first row. Okay, so it is multiplied by 2 by 3 into the key element row. Okay, key row, which is the new one. Okay, always remember this is the new one. Don't take key row from the old table. This is the old table. We have to take the new values which we just now found. Okay, these values are the key rows, new values. Okay, close it. Now R1 old. Quickly tell me what are the values? 2 by 3, 1, 0, 1 by 3, 0, 0, and 8 by 3. Okay, so all these values there. Okay, minus 2 by 3 into minus 2 by 3 into 3 into minus 2 by 3 into okay, what is a key row new? That is here key row new is 100 minus 2 by 41. I'm writing 1 0 0 minus 2 by 41. Okay, minus 12 by 41. Then 15 by 41. And last 89 divided by 41. Okay, close it. Okay, tell me the answers. Minus 2 by 3, 2 by 3 minus 2 by 3, 0. 1 minus 2 by 3 into 0. 2 by 3 into 0, 0. So 1 minus 0, it is 1. Now this number is 0. 0 minus 0, it is 0. Over here, it is 1 by 3. Okay, minus and minus plus 2 into 2, 4 divided by 3 into 41. Okay, do it in your calculator. 1 divided by 3 plus, I'm putting a bracket, 4 divided by, see it is 3 into 41 now. Either you do together or put a bracket and do for that. Okay, you will calculate 3 into 41 and then substitute. 3 into 41, okay, I'm putting over here, divided by bracket I'm putting. Can you see the, okay, can you see the calculator? 3 into 41. Okay, wherever you can put a bracket, it is always safe to put brackets. Okay, and then I'm going to close it. Okay, it is 15 divided by 41. Okay. R1. 15 divided by 41. And then again over here, this one. This is minus and minus, it will become plus. Okay. Can you cut anything? No. Okay, it is 24 divided by 3 into 41. Minus and minus plus 24 divided by 3 into 41. Okay. That is 24 divided by. Just give me a second. Yeah, 24 divided by 123, which is equal to 8 by 41. Okay. Now next one. So you can cut over here. This is 5. 2 into 5. Here you have already negative. Okay. 2 into 5 is 10 divided by minus 10 divided by 41. Okay. Over here. 8 by 3 minus. Okay. You have to solve it. Okay. So it becomes 2 into 89, which is equal to 178. 41 into 3, which is 123. Okay, now solve that. 8 divided by 3 minus 178 divided by 123. Okay, that is 50 divided by. Okay, just give me a second. This is R1 new. Yeah, it is 50 divided by 41. So in the calculator also we have got 50 divided by 41. Okay, that is R1 new. Next we have already found R3 new. See R3 new. We have found R1 new. Next we need to find R2 new. Okay, tell me the operation. R2 new is equal to R2 old minus number above. Second row is what we are considering. Number above or below the key column is key row. Sorry, key number is, what is the number? Minus 4 by 15 into key row new. Okay, tell me the values. That is minus 4 by 15, then 0, 1, minus 2 by 15, 1 by 5, 0, and 14 by 50. Okay, now minus of, I'm writing this minus 4 by 5, oh, sorry, minus 4 by 15 into 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 minus. Okay, now key row elements. Can you see? This is the key row. New key row elements from here. It is 1, 0, 0, 1, 0, 0, minus 2 by 41. Then minus 12 by 41. Okay, minus 12 by 41. Then 15 by 41. And 89 divided by 41. Okay. Tell me the answers. This is minus 4 divided by 15. Here minus and minus, it will become plus. So minus value plus the same value you will get 0. Okay. Then this number is 0. 0 minus 0 is 0. This number will become 0. 1 minus 0, it is 1. Over here. Okay. Minus 2 by 15. Okay, here you have how many minus you have? 1, 2 and 3. Okay, minus into minus into minus is again a minus. Okay, 4 into 2, 8 divided by 15 into 41. Okay, just do it in the calculator. Minus 2 divided by 15 minus, I'm putting a bracket open, 8 divided by 15 into 41. Okay, 15 into 41, bracket open. Okay, the value is, just give me a second. And just 1 second. This is equal to minus 2 by 15 minus 8 divided by 15 into 41. It's 1.5. Okay. Plus 2 divided by 15 minus 8 divided by 615. Yeah, it is minus 6 by 41. See, minus 6 by 41. Minus 6 divided by 41. Now again over here, 1 by 5. See here, minus into minus into minus. Okay, that will become minus. Okay. Can you cut anything there? Yeah, it will become 4 by 5. Okay. So the value will be 16 divided by 5 into 41. 205. Okay. 1 divided by 5 minus 16 divided by 5, which is equal to 5 divided by 41. Okay. This will become 5 divided by 41. Here minus into minus plus. Okay. 5 and 15 and 15 you cancel it. 4 divided by 41. Over here you have 14 divided by 15. Minus into minus will become plus. Okay. Then this value you can do it on the calculator. Okay. 89 into 4. 4 is 356 divided by 41 into 50. 615. Okay, which is equal to 14 divided by 15 plus 356 divided by 615. Okay, it is 62 divided by 41. Okay, 62 divided by 41. Okay, so we have got all the values correct. Now we have the third iteration. For exam, you will have only till maybe 2 iterations only, but this is for a safe side. You do bigger problems, it will be more easier for you for the exam. Okay. So again, repeating the same steps. Cj, can you tell me the values of Cj? Coefficients of Cj means coefficients of the objective function that will not that will remain the same. Okay, so we have 3, 5, 4, 0, 0, 0, 3, 5, 4, 0, 0, and 0. Now the values will be here x1, x2, x3, x1, x2, x3, s1, s2, s3. Over here we have the basic variable. We have the coefficient of the basic variable. Here we have the solution that is represented by xb. Here we have the minimum ratio. Okay. In this one, which variable left out and which variable came inside? Can you tell me from this? S3 is the outgoing vector and x1 is the incoming vector. Okay. So instead of S3, I'm writing x1. Okay. X1. So x1, the coefficient of x1 is 3. The other two variables will remain the same. 5x2, 5. You see that? 5x2 and 4x3. Okay. 4x3. Instead of S3, we had x1. Okay. So I have written x1 here and the coefficient of x1 is 3. So 3 here. Okay. Now quickly write down the values of R1, R2 and R3, new values. Okay. Yeah. R1 new is given over here. Okay, these are the new values of R1. That is 0, 1, 0. Then 15 divided by 41, 8 divided by 41, minus 10 divided by 41, and 50 divided by 41. Okay, then R2. Where is R2? Yeah. Here. Okay, this is R2 values, R2 new. Okay, 0, 0, 1, 0, 0, 1. Then minus 6 by 41. Minus 6 divided by 41. Then 5 divided by 41. Okay, then 4 divided by 41. And 62 divided by 41. 41. Okay, now R3 values. R3 values. See, R3 new. I have 100, 100, minus 2 divided by 41, minus 12 divided by 41. Okay, 15 divided by 41. 41, 89 divided by 41. Okay, I have written those values there. Next, what do? You will calculate Zj. Can you tell me the values of Zj? 5 into 0 plus 4 into 0 plus 3 into 1, that is 3. Okay, 5 into 1 plus 4 into 0 plus 3 into 0, that is 5. Again over here, this 5 into 0 plus 4 into 1 plus 3 into 0, that is 4. Next one, you have to do a little over here. 5 into 15 divided by 41 plus 4 into minus 6 divided by 41 plus 3 into minus 2 divided by 41. Okay. Okay, the value, can you calculate and tell me? Okay, what will be the value here? $75 divided by 41. Here it will become minus. Okay, we have a minus here. So minus 4 into 6, 24 divided by 41. Here again you have a minus. So minus 3 into 2 is 6 divided by 41. Okay. So everything is 41. Just do the 75 minus 24 minus 6. Okay, which is 45 divided by 41. Okay, yeah, 45 divided by 41. So I have just taken these numbers. Since the denominator is the same, I can take all the numerators together and then 75 minus 24 minus 6, that is 45. Okay, so here it will be 45 divided by 41. Okay, similarly for the next one, this values 5 into 8 divided by 41 plus 4 into 5 divided by 41 plus 3 into minus 12 divided by 41. Okay. 40 divided by 41 plus 20 divided by 41 minus 3 into 12. 36 divided by 41. All the denominators are same. So take only the numerators. 40 minus 20, sorry, plus, no, plus 20 minus 36. Okay, which is 24 divided by 41. Okay, next one more number there. Okay, what is the value? 5 into minus 10 divided by 41 plus 4 into 4 divided by 41 plus 3 into 15 divided by 41. Okay, tell me, that is minus 50 divided by 41 plus 16 divided by 41 plus 3 into 15, 45 divided by 41. Take only the numerators, minus 50 plus 16 plus 45, which is 11 divided by 41. Okay. So this is 11 divided by 41. This is 24 divided by See, 24 divided, I'm writing it on top, okay? 24 divided by 41, okay? Then again, for this value also, you need to find it, okay? So that is 5 into 50 divided by 41. 50 divided by 41, then 4 into 62 divided by 41, plus 4 into 62 divided by 41, plus 3 into 89 divided by 41. 3 into 89 divided by 41. Okay, this one. Okay, that is 250 divided by 41 plus 62 into 4, which is 248. 1 plus 89 into 3. 267 divided by 41. All the denominator is the same. So just take the numerator and add them and see. 250 plus 4, 248 plus 267. 267, which is equal to 765 divided by 41. Okay. 765 divided by 41. I'm writing it on top. 765 divided by 41. Okay. Now what do we do next? Cj minus Zj. Okay. Cj is this one. Zj we have 3 minus 3, 0. 5 minus 5, 0. 4 minus 4, 0. 0 minus 45 by 41. That is minus 45 by 41. 0 minus 24 by 41. It is minus 24 divided by 41. 0 minus 11 divided by 41. That is minus 11 divided by 41. Okay. Can you tell me the optimality? Is it optimal now? Cj minus Zj. Is it optimal now? Yes, it is optimal. Why? Because all the values, okay, each number is either 0 or less than 0. Okay, they are negative numbers or 0. So it is optimal. Okay. So finally we have reached our solution. Okay. So you need to find out the values of x1, x2 and x3. Correct? No, that is what our answer should be. We have to find out what is the values of x1, x2 and x3. Okay, from this table, see, we have written something called a solution. Okay, solution, that is 50 divided by 41, 62 divided by 41 and 89 divided by 41. These are going to be our solutions. Since this is our optimality condition is reached, this is going to be the solution. Okay, so here we have x2, right? Here we have x2. So the value of x2 is going to be 50 divided by 41. The value of x3 is going to be 62 divided by 41 and value of x1 is 89 divided by 41. And what is the value of z? The optimal value of z. Okay, our question was maximize, right? You remember our question? Okay, our question is maximize. See here, maximize z. Okay, so maximum value of z is obtained at which value? Z value. This is the value of z. Okay, or our z star. Okay, in our case, this is z itself. Sorry, our case, this is z. Okay, z maximum value is obtained at 765 divided by 41. This is going to be the maximum value of z. Okay, at which points? X2, this value, X3, this value, and X1 is this value. Okay, so finally we can write the solution. Okay, so what is going to be a solution? We have all Cj minus Zj is less than or equal to 0. So we have reached the optimal table with x1 is equal to 89 divided by 41. Okay, see, x1 is the last value. So it is 89 divided by 41. x2 is equal to 50 divided by 41 and x3 is equal to 62 divided by 41 and finally the value of z is equal to 765 divided by, finally the value of z is equal to 765 divided by 41. This is the optimal value of z. Okay, optimal value of z. Okay, to check your answer you have a easy method. We have reached a solution. You need to check your answer, no? For that, I will tell you an easy method. See, this is our question. Our question at the z in the value in the, which is our objective function. Objective function is, okay, objective function and then maximize z is equal to 3x1 plus 5x2. 3x1 maximize 3x1 plus 5x2 plus 4x3. Our question, okay. 4x3. Okay. Substitute these values. We can answer like take values x1, x2, x3. That's we maximize equation. Substitute. Okay. Which is equal to 3 into what is the value of x1? 89 divided by 41 plus 5 into. Okay. x2 is there. That is 50 divided by 41 plus 4 into x3 value and 62 divided by 41. You will understand the value will be 765 divided by 41. See, this value will be same. This value will be same as your table value on it. Okay. This value will be same as this value. Just do and see. Okay, upon minimization problem, homework item. You just check. Okay, negative objective function lighter. We need a last x1, x2, x3 values we just check. Okay, so like this you will be able to understand whether your answer is correct.